Okay, Calc, I'm skipping over section 2.5 because we're going to do that when we come back on Monday or Tuesday of next week. But we're going to talk about chain rule today. And then this is the homework assignment for it, but you won't be able to do all of these. You'll only be able to do maybe like the first four, okay? So that's all you're going to have to do for homework is maybe the first four problems. I don't know. I haven't really looked at which problems are which, but we're only going to get partway through this. And then... Yeah. And then if you haven't already done the homework for 2.4, which was product rule and quotient rule, here is that. So use your time to work in class at the end of the period to make sure you get these done, and then like the first four problems of the chain rule. But let's talk chain rule quick. Let's do power rule first. So we have the four rules. The power rule was if you have x to the nth power, then comes down in front, x to the n minus 1. That's how you do the power rule, right? The product rule, the rule for the product rule, was if you have an f and a g multiplied together, the derivative will be f prime g plus g prime f, okay? The quotient rule is if you have an f divided by a g, and this is f prime g minus g prime f all over g squared. Okay, so kind of the similar top, but one's plus, one's minus, and then we have a g squared on the bottom. And then the chain rule says this, okay, and this is going to get a little confusing because you haven't seen this before, you don't know how this works, but just write this down, okay? The chain rule says it's kind of like you have something like an x to the nth power, okay? So it's like something inside of here that's other than x, right? But we'll just leave x there to begin with, and I'll show you kind of how this operates, okay? You still do the general power rule, right? You bring the n down in front, so n x to the n minus 1. It's just now you multiply by x prime, and you're like, what the heck does that even mean? Okay, so here's the rule, right? Let's do an example of this, like when you would use the chain rule, okay? So you use the chain rule for something called a composite function or a composition of functions, right? Composition means one function stuck inside of another function. So let's say I have like, I don't know, we'll make it really easy. Let's say I have we'll go x squared plus 3 to the third power, right? Well, one option I could do is I could take this and FOIL this out 3 times, right? And then I could just do the straight power rule to that, right? But that's more work than I want to do. And imagine that like this is the 7th power instead. Like I really don't want to do that, right? So this is a chain rule. This is when we would use the chain rule because it's a function inside of another function. It's x squared function inside of something to the third power, right? So it usually involves parentheses, but every once in a while you'll have like this is also considered a composite function. So it is x plus 5, let's say, trapped underneath of a square root. So it's like two functions kind of going. It's like this linear function underneath of a square root at the same time. Okay, so that's another example of when you would use a chain rule. But here's how this works. Let's take the derivative of this guy, right? Let's say we do just the straight power rule, and the power rule says you bring the 3 down in front, right? So this is 3 times x squared plus 3. But now I have to take him to the second power because I subtract 1, right? And then the last little bit is I have to multiply by the derivative of this inside stuff, right? The derivative of x squared plus 3. And the derivative of x squared plus 3 is 2x. And then the only thing I do to simplify him ever is I take this outside number and I multiply him by this. So he is 6x times x squared plus 3 to the second power. That's all I ever do to simplify him, okay? So do you remember when we were learning product and quotient rule, I gave you like something real easy and I said, oh, okay, let's look at this in terms of power rule and in terms of product and quotient rule. So I'm going to do the same thing for chain rule. Let's say I have, I don't know, let's just say we're taking the derivative of x to the 4th power, right? We would normally use the power rule, right? And the power rule says I bring the 4 down in front, x to the 3rd power, right? Like that's what it says, right? But here's what the chain rule says. The chain rule says I bring the 4 down in front, I take x to the 3rd power, but then I take the derivative of the inside, or like what is to the 4th power, but what's the derivative of x? 1, right? So anything times 1, that's just going to stay 4x cubed. So the chain rule, just like the product rule, just like the quotient rule, also supports the power rule, right? So that's just kind of how that works out. The thing that's inside the 4th power was x. I take the derivative of the inside, and then we multiply them together, and that's how that works. So there's how that is. Chain rule you want to use for a composite function. Let's see. Oh, I don't want to do example 1. And I don't want to do example 2 because those have cosines and tangents, and we don't know how to do that yet. So I might make up some of my own examples. This one, example 4, go down to example 4, which is on the next page. This one doesn't have a trig function like these do because we don't know how to do those yet. I skipped over 2, 5 because I want you to learn the chain rule first before we start to do trig function stuff to it. Okay. Actually, you're gonna kill me. Go back to the first page. Let's do something easier before we start doing square root stuff. Let's do some more stuff over here. Let's do 2 more examples before we do a square rooty thing. Okay. Let's do, I don't know. Let's do, I don't know, 4x cubed plus 7x to the 5th power. I don't know. Let's do that. Okay. Chain rule says, just like power rule, 5 comes down in front. Leave the inside. Now it is to the 4th power. Okay, but now I have to take the derivative because it's not just x to the 5th power. I don't just get to take and say 5x to the 4th. Don't get to do that, right? Now I have to take the derivative of the inside. And the derivative of this guy is 12x squared. And the derivative of 7x is plus 7. Okay, now the only thing again that I simplify is I take this 5 times this stuff. Okay, 5 times 12 is 60x squared plus 35. And then I've got this stuff behind him. Plus 7x. And if you leave your answer like that, I'm going to count it wrong because now it looks like the only thing that I'm taking times this guy is 35. So because there's multiple pieces here, I need to put a parenthesis around that as well. So there's that. All right, let's do another. Let's just do another one. Let's like that. I'm going to do, I don't know, the same type of thing. Okay, let's do this. I like this one. Let's do 1 over x, we'll go 2x plus 3 to the 4th power. Let's do that. That's kind of funny, weird. Now, we could use the quotient rule because that's technically a quotient, right? But I don't like to use the quotient rule because the quotient rule is a lot of steps and the chain rule is faster, okay? So here's what I'm going to do. I'm going to do like we've done before where we bump this to the top, right? Like if we had like 2 over x, I would bump this x to the top and be x to the negative 1. Then I do the power rule and all that stuff, okay? But I'm going to move that to the top, and when I do that, it's going to just become 2x plus 3 to the negative 4th power on the top, like over 1, right? Like that. Now I can apply the chain rule again, okay? So negative 4 is going to come down in front. 2x plus 3 to the negative 3rd power now. No, wrong. To the negative 5th power because I'm subtracting 1, right? To the negative 5th power, but I have to multiply by the inside, or the derivative of the inside. Derivative of 2x plus 3 is just 2. Okay, now I'm going to multiply these two guys together, and that's negative 8. But then this whole thing is to a negative 5 power. So I'm going to bump him to the bottom, and he is going to be to the positive 5th power. Okay, now that's what it would have reduced to if I would have done the quotient rule on him. Okay, so just so you know, that's fair game too. You can use stuff that you would normally do a quotient rule to. You can do the chain rule. Now, I probably wouldn't be able to do just the chain rule if this was something other than 1. Like if it was 2, I guess I could do that if it's a constant. But if it's like x plus 4, I probably wouldn't be able to do the chain rule to that, right? Because then I'd have another variable to deal with, whatever, right? So there's that. I would have to use probably the quotient rule if that's the case. But there's how that works. All right, now let's go down and do our square root guy. All right, do your very, very best to follow along. Here we go. This guy, square root. Anytime you see a square root before you take the derivative, change it to the 1/2 power. So this guy is now to the 1/2 power. We're rewriting him as the 1/2 power. All right. Just like normal, just like the power rule, I would take the 1/2 out in front. I'm going to leave the inside x squared plus 1. And I'm going to take it, if I subtract 1 from 1/2, he will now be to the negative 1/2 power. Okay? If this was the power rule, I'd be done at this point. I'd still have to fix this negative, but I'd be done. But now I have to take the derivative of the inside. I'm doing them in a different color even. Derivative of the inside derivative of x squared plus 1 is just 2x. Okay, now let's just think a bit on this, because sometimes this gets really ugly and confusing. I usually combine this guy and this guy. 1/2 times 2x. 1/2 times 2x is just x, right? Okay, but now this whole thing is a negative exponent, and that means he's going to go to the bottom, right? So he is going to be x squared plus 1 to the positive 1/2 power now that he's on the bottom. But that means that that's the square root of that stuff. Okay, good, maybe. All right, let's do one more. I'll add this in here. Let's say that we have the cubic root of, I don't know, we'll make this like, let's just say we have the cubic root of 5x. I don't know, right? It doesn't have to be x plus anything. This is just could just be the cubic root of 5x, right? All right, so let's do this. This will end up, before we take the derivative, he will be 5x to the 1/3 power. All right. So the rule says, the quotient rule, or excuse me, the chain rule says the 1/3 comes down in front. I've got 5x. And if I subtract 1 from 2/3, or excuse me, from 1/3, it will be to the negative 2/3 power. But because this is something trapped inside of an exponent, right? It's not just x to the 1/3. If it was x to the 1/3, I do the power rule and I'm done, right? But here I have to do the chain, okay? And you might be like confused because you're like, well, why can't I just do the 1/3 times the 5? That would be if it was just x to the 1/3. But since 5x is all underneath of the 1/3, I can't just take this 1/3 times 5, right? Because the 5 is also to the 2/3 power. Clear as mud. I've really confused you now, okay? So because that 5 is trapped inside of the 1/3 power, I can't just take this 1/3 times this 5. That doesn't work like that, right? So I have to multiply by the derivative of the inside. Derivative of 5x is just 5. And now I'm going to put stuff together. Okay, 1/3 times 5 is 5/3, right? But now since this is to a negative exponent, I'm going to put him down to the bottom, and he's going to be 5x to the positive 2/3 power, right? So I've fixed everything, and that's how I'm going to make him look. I'm going to put him down here with the 3, because the 3 is technically on the bottom, right? And then I'm going to fix that 2/3 power, so 5 is on the top. I've got 3, and the 2/3 power means the cubic root of 5x squared. Now you could do one more and say 5x squared is the same thing as 25x squared, right? And get rid of the parentheses, right? It doesn't matter, whichever. I'm going to leave them like this, actually. So that's how that works when you have roots, okay? You just do it kind of straight. Chain rule is like power rule. Chain rule is exactly like power rule, but you just take it times the derivative of what the inside stuff is now also. Okay, and these all have trig function stuff. Okay, so what I want you to do is, for homework, try doing those first 4 problems, or look at these problems and see which ones of those don't involve a trig function like sine, cosine, tangent. If there are any, I hope there are. But try to do those. If you have not yet finished the 2-4 homework, do that, okay? Which is these guys right here. Just as a foreshadowing of what we'll bring tomorrow, I'm going to wait to teach you derivatives of trig functions until I'm actually in class with you. So that'll be like Monday, Tuesday maybe. But tomorrow I'm going to give you this half sheet of paper that has these rules with a problem. And this is going to be like your cheat sheet, right? Here's the formula for those. We're going to fill this out, and then we're going to find the solution for these problems, right, using those rules, okay? Then what I'm going to have you do is I'm going to give you this sheet for homework, okay? This one that says power quotient, product, and chain rule review. And it has a 1 through 12 on this side. And there are 4 power, 4 product, 4 quotient, 4 chain. Does that end up being right? No, that doesn't add up to 4 or 12. There are 3 of each. 3, 3, 3, 3. And what we'll do tomorrow is we'll go through those after we fill out your cheat sheet. We'll go through those, and I'll have you do those for homework. Okay, so make sure that you get 2, 4, and 2, 6 done. All right, you've got lots of time in class, I think. There you go. Goodbye.